Hello everyone. Welcome to the CNS channel where we delve into the intricacies of building the microservice applications using Spring Boot, Spring Data JPA and Java 17. In today's video, we will explore the Spring concepts and coding practices behind building a microservice application based on a three-tier architecture. Whether you are a seasoned developer or an aspiring architect, this video is tailored to provide valuable insights and practical guidance on designing and implementing microservice applications using industry standard technologies. As we navigate through the various concepts and code snippets, let's dive in and embark on this journey of exploring microservice architecture with Spring Boot, Spring Data JPA, and the latest feature of Java 17. Let's move on to the concepts. What is Spring Framework? The Spring Framework is an open source framework for building Java-based enterprise applications. It simplifies development through features like inversion of control IOC, dependency injection DI, and models of various aspects like data access, transaction management, and web development. It promotes models and maintainable code, right? What is the benefit of Spring Boot? The Spring Boot is an open source Java-based framework that simplifies the process of developing and deploying production-ready applications. It builds on the core concepts of the broader Spring framework, but focuses on convention over configuration, allowing developers to quickly set up and build applications with minimal manual configuration. Spring Boot provides built-in support for various features like embedded web servers, dependency injection, and auto configuration, making it well suited for developing microservices and standalone applications. Moving on to application context. In Spring, the application context is a container responsible for managing the lifecycle of beans is nothing but components in a Spring application. It provides services such as dependency injection, event propagation, and access to application components. The application context is an extension of the Bean factory interface and includes additional features for enterprise applications. Bean definition in Spring. A bean is an object that is instantiated, assembled, and managed by the Spring IOC container. The configuration metadata that the container uses to understand how to create, configure, and manage beans is known as the bean definition. The bean definition contains information about the bean such as its class, scope, lifecycle, callbacks, and dependencies. Moving on to next, what is Spring scopes? In Spring, we have various scopes. We can look at one by one. Singleton scope. There is only one instance of the bean per Spring IOC container. The same instance is returned for every request for that bean. It is the default scope in Spring. Next, prototype scope. A new instance of the bean is created for each request. This scope is useful when you want to create a new and independent instance for every use. Next, request scope. A new instance of the bean is created for each HTTP request in a web-based application. It is valid only in the context of a web-aware Spring application context. Next scope, session. A new instance of a bean is created for each HTTP session in a web-based application. Like the request scope, it is valid only in the context of a web-aware Spring application context. Global session scope is similar to the session scope, but it is typically used for global session beans in a portlet-based web application. Next scope, a single instance of the bean is created for the entire life cycle of the application. It is valid only in the context of a web-aware Spring application context. Key features of the Spring framework. The inversion of control container manages the components of a Spring-based application. It allows developers to define and configure beans and manages their lifecycle. Dependency injection. Spring promotes the use of dependency injection where components are injected with their dependencies rather than creating them within the component. This makes the code more modular, easy to test, and reduces tight coupling between classes. Data access. Spring provides support for data access through JDBC and object relational mapping frameworks like Hibernate. We are going to use JPA in our upcoming application. It simplifies database access and transactions. So JPA is built on top of Hibernate. We will talk about in details in the upcoming video. Transaction management. Spring simplifies transaction management in Java applications by providing a consistent programming model for both local and distributed transactions. Model View Controller. The Spring MVC framework is an extension of the Servlet API that simplifies the development of web applications. It follows the Model View Controller architectural pattern. Security. Spring Security is a powerful and customizable authentication and access control framework for Java applications. Integration. Spring provides integration with the various technologies and frameworks, including Java EE, JMS, Java Messaging Service, JMX, and more. Testing. Spring supports testing through the use of the Spring Test Context framework, which simplifies integration testing and unit testing of Spring components. Modular. The modular nature of Spring framework allows developers to use only the parts they need, promoting a lightweight and flexible development approach. The Spring framework has evolved over the years and has become a popular choice for building scalable and maintainable enterprise application in the Java ecosystem. Let's get started for the coding part. First of all, I can show you what is the IntelliJ version I have, and then runtime I have Java 17. Let me show you what is the settings I have. Java 17 and then IntelliJ selected for build and run to my code. So here when I say this is a three-tier architecture, we should have controller, service and a repository. In the controller, uh, we have endpoints which is exposing outside from this application. If anybody wants to consume and send the request or get the response, they will do it. These are the dependency I have for my application. I have all latest dependency to build this application. I can navigate the code from the controller. I can take the product controller. So I'm using Restful controller. Restful controller is primarily designed for the RESTful web services. I'm going to start from the product controller. The product controller has the endpoint of slash API slash products. I can send the request to this controller from the postman as a JSON request, and then it will give the response as a JSON to the postman when I post it. I have post method to create the product. So it will go to the service. So in this service, I have one create method. Here I am using the Java 17 features, which is sealed. So I use the sealed here and permits to the product service IMPL class. When I am using the sealed feature, I need to use the final on the class so that it will be maintained as an isolated hierarchy for the encapsulation. And then the service class is calling the repository to save the object to the database. So in this repository, I have this code. This is the code I have. I'm using the default method for saving the object to the database. Similarly, I have the store grocery item controller, the same flow but for the different um, table can save the records. I used the record class for my DTO. This record class is introduced in Java 16, and then people are continuing to use this. This class is well suited for the DTO class to transfer the data between the layers from one application to another application layer if you are in the same application. This record class is not suitable for entity because this is the final class. Once the object is created, it cannot be modified. And then entity class here, I can, so if you see the product record, you have the ID, product name, price, and description. And then for this entity, I have entity class. In this entity class, I'm generating the ID sequentially. It can create automatically when record is going to save, right? And then one important thing I need to say that since I'm using the latest dependencies, I should use Jakarta persistence. Otherwise, if I use Java X persistence, this will not accept. It will throw error. So be cautious about using the entity. So let me repeat one more time. So when you are developing the entity class, you can use Jakarta persistence packages for using the entity annotation and ID and other annotation which is required for entity class. If you use Java X persistent, it's not working. They need to provide the fix or Spring side, something needs to be adopted. Right now, Java X dot persistence is not working. I tried. If you want to see the error, I can show you. Um, and then another important thing which you need to look at here, I'm transferring the data from the entity class to the record class. I'm using this mapping since I'm having the same property. So I don't want to do the manual mapping from entity class to record class. It can map automatically. For that, I need to use this mapper annotation, and then this is the map struct. I'm using it for transferring the data from entity class to record class. This also one of the main point you need to note it down while developing this application. And then you need to use component model as a Spring so that you can do the auto wire for this interface. You don't want to do the implementation class. Instead, when you are compiling it, the implementation class can be auto generated here. Okay, so if you are modifying any property in the record class or the entity class, you need to modify this interface to reflect in the auto generated class. That also one of the important point you need to note it down. Now I'm going to run this application and then we can see the API, how it is transferring the data from the postman to the database, we can look at quickly. So first I can build the application. Okay, now I'm going to run the application. Before that, I'm going to connect my H2 database. I don't have any record here, so I'm going to post the request. I'm going to save this product to my H2 database. It is saved. Let us look at right now. Okay, this record is saved. Now I'm going to test the another API. So here you might have looked at um, so this store item records and then store item. So here I have one-to-one relationship and then joint table is the product ID. Accordingly, I framed the request here, sending. Okay, this is also saved. We can look at the record now. Okay, the quantity is saved and then auto-generated ID and then a foreign key saved here. And one more item I need to explain here. I'm using the enable JPA repository to reference to the repository package. Entity scan I'm using for the entity package to be identified by the Spring application. Okay, I can show you the problem if I use the Java X persistence. Okay, so application is running and then we verified the records. Now I'm going to show the problem if it happened, if you use it. What is the error you will get? Application built successfully, but when you are going to run the application, provided the error, it says error creating bean with a name, right? And then you will have the problem of this association problem. So you might think that I'm not consistently using all the entity, but that is not the case. This is independent entity. Okay, so if I go back to the previous package, it can resolve the problem. See, thanks for watching. If you like this video, please like and subscribe, share to your friends. You will receive more videos from this channel. Thank you everyone.